so we are going to do problem 40 in the book, page 45. Okay, so it says Jim has four more than three times as many baseball cards as Carlos. So let's start right there. Jim has four more than three times as many baseball cards as Carlos. So, what do you think? What do you think we got going right there?
Seven. Wait, what do you mean? What, like seven? Like what numbers or what?
So four. So let's start with Jim has. How do you think we write that in a math sentence?
Jim
Did you turn off
has?
your camera?
No.
Oh, okay, weird. Didn't show up. All right, Jim has. How do you think we? What the amount of cards that Jim has? We want to write a variable for that. What do you think we should use?
X. Oh, J.
J. J would be better. So J, the amount of cards that Jim has is equal to. So J equals the amount of cards that Jim has. What other variables could we use? What else don't we know by reading the sentence?
How many cards? Oh, that sentence. Jim has four more than three as many cards as Carlos.
So,
We don't know how many cards Carlos has.
all right. So what could we do to represent the number of cards Carlos has?
C.
All right. So we can say that C, first part of our algebra problems is usually what are our variables? So now, that's the first step. Now we want a phrase that'll combine our two variables together. So, what does our sentence say?
Jim has four more than three times as many cards as Carlos.
All right. So let's take that. Let's work backwards a little bit, or maybe not. So the amount of cards that Jim has. So how do we write that?
7.
Well, no. So
Oh,
what am I saying? The amount of cards Jim has. What do we do to write that?
J.
J. We just write J. So J equals the amount of card that Jim has equals what?
7.
Don't say 7. We're reading that. Read it. Read it as we see it. Four more than. What is four more than? How do we write four more than?
Four more than. How would you write that?
How would we write that as a math sentence?
Set 4 plus 3, right?
Where are you getting 3 from? What am I saying? I'm saying four more than. I'm saying nothing else. We're not thinking about anything else in the problem right now.
4 more than.
How do we write that as a math phrase?
Plus 4.
Plus 4, right? 4 more than what?
4 more than 3.
That's not what it says. 4 more than what?
4 more than 3 times.
3 times what?
As many cards as Carlos.
What do we use to represent as many cards Carlos has?
C.
All right, so read that. So read that sentence again. That part again.
4 more than.
Start at 3. Start at 3.
3 times as many cards as Carlos.
And what can we say instead of saying as many cards as Carlos?
C.
So we can say 3 times C. How do we write 3 times C?
3 period C.
Or 3 dot C, sure.
3 dot C. Yeah.
Okay, so 4 more than 3 dot C. Yes?
What slide are you on?
I'm on slide 14 still.
That didn't come up.
Well, I haven't written it yet.
Oh, there it is.
So this says 4 more than 3 times C, right?
Yes.
Okay, does that make sense?
Yes.
Okay, we just got to take it slow. Because what were you doing? You had a 7. Where'd you get that 7 from?
I don't know.
Right, you were rushing. We have to think about one part at a time. If you try to bundle too much of it together, you're going to get lost and start going down the wrong path. We got to take our time. Okay. Now let's take a look at question. What was the one you asked about? 46.
Wait, so what's the answer to the one
We just got it. So what was the question actually?
for me?
What was the question in question 40? What was the final question?
If Carlos had X cards, how many does Jim have?
All right.
We never figured that
So
out.
the question is, how many cards does Jim have? What
Yeah.
does J represent?
Amount of cards Jim has.
So the amount of cards that Jim has is equal to 3C plus 4. We don't know exactly how many he has until we know exactly how many Carlos's has. But because we don't know exactly how many, that's why we use variables, because we don't know exactly how many yet. When we find out, let's say Carlos has 1 card. How many cards will Jim have?
3 times.
Replace the C with the 1. All right, read me this. What does this say in math?
J equals 3 times C plus 4.
Okay, just this part now.
3 times C plus 4.
Now, if we replace the C with a 1, what does it say?
3 times 1 plus 4.
What's 3 times 1 plus 4?
3 times 1 is 3 plus 4 is 7.
So if Carlos has 1 card, how many cards does Jim have?
7.
Right, okay. What if Carlos had 2 cards?
14.
Walk it through the process.
3 times 2 is 6 plus 4 is 10.
All right. So if Carlos has 2 cards, how many cards does Jim have?
10. Wait, say 2 cards?
Yep.
Carlos had how many cards? 2?
Yep.
He'd have 10.
Right, okay. If Carlos had 10 cards, how many cards would Jim have?
If he had 10 cards, he'd have 34.
Good. Does that make sense?
Yeah, but so we never got an answer then.
This is the answer. What we want is a math sentence that allows us to put in the number of cards Carlos has. Because right now, do we know how many cards Carlos has?
No.
No, but later on, if we find out, we can use it, right? We just used it 3 different ways. We just used it for 1 card, 2 cards, and 10 cards. And we did it quickly.
This is the right answer.
This is the answer. So the question was, how many cards does Jim have? Jim has this many cards relative to Carlos. Because the statement was, if Carlos had so many cards, how many cards would Jim have? Well, we don't know how many cards exactly, so we're going to write a sentence that uses a variable for Carlos's cards. We don't know how many cards Carlos has, so we're going to use a variable. So we're going to write a sentence with a variable that lets us know how many cards Jim will have. So this is our answer. It's a phrase. It's not a word. It's not a single word like 7. It's a whole phrase like this. That's what we're going to see a lot of the times in these algebra problems. It's not going to be something small. It might be something spread out like this. Let's take a look. Let's take a look at question 46. So, what's a consecutive number?
Consecutive number. Hold on, my bad. I don't know.
What is consecutive? When have you heard the word consecutive before?
I've never.
Consecutive means one right after the other.
Oh, yeah.
So what are some examples of consecutive numbers?
3, 8, 9.
If we're looking at a number line, which numbers are right after the other?
1, 2, 3, 4, 5,
There
6,
you go.
7, 8,
So
9.
consecutive numbers. So if we start at 10, what are the consecutive numbers after 10?
11, 12, 13, 14,
If we
15,
start at
16,
100, what are the consecutive numbers after 100?
101, 102, 103,
All right, good.
104,
Those are consecutive numbers. So what does the question ask us?
46.
46.
The first of the three consecutive numbers is x. What are the other two?
Okay, so let's think of three consecutive numbers. Give me an example of three consecutive numbers.
27, 28, 29.
Perfect. Okay, so you have, we'll write that down. You on slide 15?
Yeah.
27, 28, oh shoot, 28, 29. All right, so what is it? What does our question say again? What's that if statement?
If the first three consecutive numbers is x.
If the first of three is x.
Oh.
So instead of writing a 27, what are we going to write instead?
X?
X, yeah. So that's the first of three consecutive numbers. So what would the next number be?
What do you mean?
If we're starting at one number and trying to get to the next number, how do we get to that next number?
Without knowing what the next number is?
Well, think about it. If we start at 27 and try to go to 28, what do we have to do to 27? What do we do to 27 to make it 28?
Add 1.
Add 1. All right, so if we're trying to get from x and get to the number right after x, what do we do?
Add 1. Add 1.
Add 1. So say that. X plus 1.
Yes.
All right. Now, let's take a look at our list up here. If we're trying to go from 27 to get to 29, what do we do?
Add 1.
27 plus 1 equals?
28.
All right. If we're at 27 and trying to get to 29, what do we do?
Add 1.
27.
If we're add 2.
Add 2. All right. So what do we do to get from x to the number 2 away from x?
Add 2.
Add 2. So x plus 2. All right. So the question was, if x is the first of three consecutive numbers, 1, 2, 3, what are the other two? Well, we have x, and then to get to the next one, we add 1, and then to get to the second after that, we add 2. X plus 1, x plus 2, just like this. 27, 27 plus 1, 27 plus 2. If we have 5, 6, 7, we have 5, 5 plus 1, 5 plus 2. Do you have any questions?
Yeah. No.
No?
It says if the first three consecutive numbers.
First of three.
If the first of three consecutive numbers. If someone walked up and asked me this question, like, I don't have three consecutive numbers, so I just make up 3. Like, is that what they're asking you to do?
So
Like,
now that we have this sentence, let's say pick a random number.
5.
5. Well, we've already used 5. Pick another random number.
24.
24. So let's say someone says, what are the consecutive numbers starting with 24? So our first number we already know is x, so x is going to equal 24. So let's replace x with 24 in all these parts. Do you see what we did there? Okay, what's 24 plus 1?
25.
All right, and what's 24 plus 2?
26.
Right. 24, 25, 26. So what this sentence allows us to do, we're able to replace it with the number, and now we're able to find the next two numbers. Okay, let's pick another number. Let's say we have 12. 12 plus 1, 12 plus 2. What's 12 plus 1?
13.
What's 12 plus 2?
14.
14. Bam. So just by knowing that first number, we're able to know the other two. That's kind of the point. We're simplifying it in a way. It doesn't make, I mean, in real life, you know the consecutive numbers off the top of your head, but they're starting you off with simple examples. That way they can work you up to more complicated examples. What I need you to do is to try your homework problems, take them slow, because it's better to try it and get it wrong than to not do anything at all. And I also need you to ask me questions during the week and not an hour before class starts because I'm not able to help you once class starts, or not able to help you with your homework when it's that late.
Okay.
I need you to try them sooner so that I can help you sooner. And then I can also make you more videos and stuff too.
All right.
Okay. So so your homework is to try all these problems again. And if you don't understand it, that's fine, but I need you to try it so that you can think of the best questions to ask me. Because if you don't try it at all, you don't know what questions to ask. Right?
Yes.
If you try it and fail, now you have some questions to ask. So your homework is to redo the page 45 evens and to rewatch this video once I post it.
Okay. All right.
Okay, bye.